Hi guys, this is Mrs. Foy, and this is an introduction to nomenclature, right? So this is how we name things in chemistry and how we write the formulas for them. So I want to start off with the periodic table, and I want to point out to you this little stair-step line that you may have seen on the periodic table. It's the great dividing line between the metals, which are everybody over on this side of the stair-step, and the non-metals over here. You can see that most of the elements in the periodic table are non-metals. And so we've got the metals and the non-metals. These guys over here are the noble gases, and we're going to ignore them for right now. They don't really react very much, and so when we talk about nomenclature, we don't usually have those in our formulas. But guys, metals tend to lose electrons. They tend to lose electrons, and so because of that, they tend to form positive ions or cations. Non-metals tend to gain electrons. They gain electrons, and so they become negatively charged ions. All right? So we've got the metals over here, and we've got the non-metals over here, and non-metals tend to form negative anions, and metals tend to form positive ions. All right. So now we're going to look at the patterns in the periodic table. So you're going to learn as the year goes on that everybody in the same column is very similar. We call these groups or families. And everybody in this group 1A tends to lose one electron. And because they do, they all tend to form a positive one ion when they form ions. Everybody in this column 2A, tends to lose 2 electrons, and so they become a +2 ion. These guys in the center don't have a really cool pattern like this. They're the transition metals, and we're going to ignore them right now. We're going to talk about those in just a minute. But everybody in this column 3A, tend to lose 3 electrons, so they become a +3 charge. We're going to skip over this column right now, and these are the noble gases, and so we're going to ignore them. But if we look at this column right here, this column 17, these guys all tend to gain electron, and so everybody here tends to form a -1 ion. Everybody in this column 16, tends to gain 2 electrons, so they like to become a +2 charge. And everybody in nitrogen's column or group or family tends to gain 3 electrons, and so they like to become a -3 ion. These guys don't often form ions, but if they do, it's kind of a pot shot if they form a +4 or a -4. All right? All right, so here we go. When we are talking about a neutral atom, if that neutral atom loses electrons, then it becomes a cation. And as we just said, metals tend to form positive ions. Neutral atoms, if they are made so that they tend to gain electrons, they become anions, and we know that most nonmetals tend to form negative anions. All right, so here we go. Let's talk about how these guys, how we say their names differently. So if you look at a calcium atom, these are all metals now, all right? You would just say calcium. And if you looked at a calcium +2 ion, you would still call that calcium if you see it in a formula. If you see plain old aluminum atom, you would say aluminum. If you see an aluminum +3, you would still call that ion aluminum. But here's the difference. If you are looking at non-metals, I'll change color here. If you're looking at non-metals, it's a little different. If you see a plain chlorine atom, you say chlorine. But if you see that it is a chlorine that has gained an electron, it is now an ion, and I don't call it chlorine, I call it chloride. If you see a plain oxygen atom, you say oxygen. If it is an oxygen ion that has gained 2 electrons, we call it oxide. All right, so that's going to become important. So guys, I'm going to teach you the rules for the simplest kind of nomenclature called binary ionic compounds. Binary, just like bicycle has 2 wheels, this means 2 elements are involved. Ionic means you're going to have ions involved. So it's going to be a positive cation and a negative anion. They're going to come together to make a compound. And so we're going to look at the formulas, and we're going to see what these mean. So NaCl, does it have any subscripts? Well, the subscripts are the little numbers down here on the bottom right. And if you don't see anything, you just assume that that means 1. So in that formula, NaCl, that means I have 1 chloride ion and 1 sodium positive ion. Notice that I don't see any charges on the superscript, like these. I don't see any of those because the charges have balanced out, so I don't see a charge there. CaBr2, that subscript means that I have 2 Br ions, and it means I have 1 calcium, which I know is a +2. If you don't know why it is a +2, it's because there's calcium right there, and it is a +2. So let's look at these subscripts. Al2o3. What this means is that means there are 2 aluminum ions and 3 oxide ions. Okay? Notice how the total positive charge here is a +6 and the total negative charge here is a -6. And so that's why I don't see any superscripts. I don't see any little pluses or minuses here because those charges have balanced out. And that's important. We always do that in an ionic compound. All right, so we're gonna try to play this little game here. So I'm gonna roll the dice here. Roll the dice here. There are some polyatomic ions in here, and oh good, I didn't get one, so that's good. So we're gonna do this today in class. But aluminum, so here's my metal. The metals always go first. So I have aluminum. Notice it's a +3 charge. And then chloride is a -1 charge. So you guys see that I am going to need 3 chloride ions to balance out the +3 charge. Do I have another one? Oh, yes, I do, right here. Okay, so the way that this would look is there would be 1 aluminum +3 ion and 3 chloride minus ions. And so the formula would be Al with no subscript because it's just 1, Cl3. And I would call this aluminum chloride. Aluminum chloride. Not aluminum chlorine, aluminum chloride. All right, so now we're going to talk about the transition metals. They do cause a little bit of headaches because they can be variable. They are going to be a positive charge, but sometimes the charges can be different. For example, with copper, sometimes copper can be a +1 charge, and sometimes copper can be a +2 charge. So if you say copper chloride, you don't know which copper ion it was, whether it was a copper +1 or a copper +2. So we have a rule for that. What we do is we use Roman numerals to show the charge. Roman numerals are these guys that look like this, right? We don't really use very many of them. So 1, 2, 3, 4, and 5 are the main ones that we're going to use for charges. And so let's see how this works. So if I am talking about a copper +1, I name it copper 1. The 1 means the charge is 1, not that there are 1 of them. This is the charge. So copper 2 would be copper +2. Manganese +4, I would call it manganese 4. That means that the charge on the ion is +4. And manganese 3 has a +3 charge. The charge on the ion is +3. All right? So when you look at compounds, you have to figure out what the charge is, if it is a transition metal. Okay? So I can't just call this copper chloride, right? I got to figure out what the charge is on the copper. And I don't know because there's different charges that transition metals can be. But chloride is always a -1, and I have 2 of them. And I only have 1 copper. Do you see that? So what must the charge be? It must be a +2. And so that's why I would call this copper 2 chloride. Here, it's going to be copper. The name is going to be copper something nitride. I have to use the Roman numeral because I don't know what the charge is. The nitride is always a -3 because I know that from my periodic table. And it looks like I have 3 coppers. And so because I have 3, because that's what that subscript means, I must have what charge on each of these to balance out the -3 here? You're right, it's got to be a +1. And so this compound would be copper 1 nitride. Here, I know this is going to be manganese something phosphide. And again, I know that manganese is a transition metal. I don't know what the charge is. But I know the phosphide is always a -3. And I only have one manganese. So what must the charge be? It must be +3 to balance out the -3 here. And so this is going to be manganese 3 phosphide. The last one, manganese something oxide, right? Oxygen is always -2. I know that from the periodic table, and that subscript right there tells me I have 2 of them. I only have one manganese because there's no subscript, and that means 1. So what must the charge be here? You're right. It's got to be a +4. So this is going to be manganese 4 oxide. So transition metals are a little bit more tricky. One thing about the transition metals is that there are some exceptions. Lead and tin are included in the variable charged metal cations. So watch out for them. They can have different kinds of charges. They could be +2, +5. I think tin is +2 and +4, so you have to watch out for those. And zinc, even though it is a transition metal, is always +2, so use no Roman numerals for that. That's bad form in nomenclature. So you don't need Roman numerals for either zinc, because it's always +2, and silver, because it's always +1. All right, let's try some of these. Strontium chloride. So I look on my periodic table. I know that strontium is a +2. Chloride is a -1. I see that I'm going to need 2 chloride ions to balance out the charge on the 1 +2 strontium, and so I would write SrCl2. No charges because the charges have been canceled out. Potassium iodide. Potassium has a +1 charge because it's in that column of the periodic table. Play back this video if you don't know how I got these, because I explained that at the very beginning. Potassium iodide, 1 of each. Super easy. Silver, I know, is always a +1. Nitride is a -3. So I'm going to have 3 silver ions, 3 silver cations to balance out the -3 here. So it's going to be Ag3N, silver nitride. Lead 4 oxide. Lead 4, that tells me the charge, Lead 5, that tells me the charge is +5. And oxide, I know oxygen is a -2. Now this one's a little challenging because I have to basically figure out the common denominator so I can get these guys to balance. So it looks like I am going to need 5 of these. 1, 2, 3, 4, 5. That's a total of a -10 here. And I'm going to need 2 lead +5. So you see how I have a total of +5, and now I have, +10, and I have a total of a -10. So I would write Pb2O5. All right? So now we're going to go to the names, from the formulas to the names. CaO is just going to be plain old calcium oxide. CuO, oops, that's a transition metal, so I have to figure out the charge. It's going to be something oxide, and it's going to be copper something oxide. I just have to figure out the charge on the copper so I know what Roman numeral to use. Oxide is a -2 charge. There is only 1 copper, so the charge must be +2. So copper 2 oxide. I have 2 more here. Lithium phosphide, that's easy. Lithium phosphide. Right? Metal and a nonmetal. And this one is just going to be plain old magnesium nitride. Magnesium nitride. All right? So practice these, and I'll see you in class, and good luck with nomenclature.